Welcome to week 1 of the half-past papers. I'm going to do one of these every single week this academic year. So it's only 40 marks instead of 80. It is for Edexcel, but if you do a different exam board, it's still going to be helpful. All of the topics that are going to appear in this paper, I've listed them here, as well as the Sparks code. So if you do have Sparks, you can also look them up and do some extra practice using those codes. Okay, great, let's begin. So question number 1, a really classic question 1. We're going to be adding mixed numbers. So when you're adding fractions, we need to make the denominators the same. With these fractions, the first thing I'm going to do though is make them top heavy. So I've got 2 and a 7th. 2 and a 7th, we're going to multiply the big number here by the denominator. So 2 times 7 is 14, and then add on the extra 1. So 2 times 7 is 14, add the 1 is 15 sevenths. So that's the first thing we're going to do. And then same here, multiplying 1 times 4 is 4, add the extra 1 is 5. So we've got 5 quarters coming from that fraction. So 15 sevenths, add 5 quarters. And we now want to make these denominators, the bottom numbers here, we want to make these numbers the same. So we're looking for a number that's in the 7 times table and the 4 times table, and that's going to be 28. So we're going to make both these fractions out of 28. And to keep them equivalent, whatever you multiply the bottom number by, you also need to multiply the top number by. So we've multiplied that by 4 to make it out of 28. So we also need to multiply the top number, the numerator, by 4 as well. And that's going to be 60. 15 times 4 is 60. With the second fraction, I've multiplied the denominator by 7 to make it out of 28. So I also need to multiply the numerator by 7, and that's 35. Now we can go ahead and add those fractions because the denominators are the same. So we keep it out of 28, don't ever add the bottoms, they stay out of 28. And I've got 60 add 35, so that is 95 out of 28. Now it hasn't said to put it back as a mixed number, so that's absolutely fine, we can leave that answer there. If it did say to give your answer as a mixed number, we would need to say, okay, how many 28s go into 95? So I've got 28, add another 28 is 56, add another 28 is going to be 84. And I wouldn't fit another one in. So I've got 1, 2, 3 times 28 goes into 95. So that would be 3 wholes. And then from 84 up to 95, that's 11 extra left over. So I've got 11 28ths left over. Now that question did not say you must give your answer as a mixed number. So this would be absolutely fine for full marks, and this would be absolutely fine for full marks, and that would be 2 marks for that question. Part B, work out 1 1/5 divided by 3 quarters. Now again, if you see any mixed numbers, we're going to make them top heavy. So let's do that first. And we're doing the big number multiplied by the bottom number, add on the top. So 1 times 5 is 5, add the 1 is 6 fifths, and that's divided by 3 quarters. Don't need to do anything to the 3 quarters because it's already a fraction, not a mixed number. And then we're going to keep, change, flip. So when we divide fractions, it's the same as multiplying by its reciprocal. And a reciprocal is a fancy word for when you're inverting that fraction and putting the denominator on the numerator and the numerator on the denominator. So there we go. We've got the same question there. Dividing by 3 quarters is the same as timesing by 4/3. And once we're timesing, this is lovely. We don't need to make the denominators the same when you're timesing or dividing. We're just going to do the top times the top and the bottom times the bottom. So that's going to be 24 out of 15. Now this one does say give your answer as a mixed number in its simplest form. So I need to think how many 15s fit into 24, and that goes in 1 whole time. 2 lots would be 30, and that's too big. And how much have I got left over? So to go from 15 up to 24, that's an extra 9 out of 15. Now that wouldn't get us full marks, because remember it also says in its simplest form. So I'm looking at this fraction part and thinking, are 9 and 15 both in the same times table? And they are, they're both in the 3 times table. So I'm going to divide that by 3 on the numerator and the denominator to simplify that fraction, and that's going to be 1 and 3 fifths. So that would be your final answer for 2 marks. Question number 3. Renee buys 5 kilograms of sweets to sell. She pays £10 for the sweets. Renee puts all the sweets into bags. She puts 250 grams of sweets into each bag. She sells each bag of sweets for 65p. Renee sells all the bags of sweets. Work out her percentage profit. Firstly, she pays £10 for all the sweets and she's bought 5 kilograms. Now she's going to put them into bags, and the bags are 250 grams each. So the first step here would be to work out how many little bags she can do. So the first thing to note is that 5 kilograms is 5,000 grams. We're working in kilograms, but we're also working in grams. So let's get them the same. 5 kilograms is 5,000 grams. Killer anything. If I said I've got 5k in my bank, a lot of you would think, okay, that's 5,000 pounds. So kilograms is 1,000 grams. So 5 kilograms is 5,000 grams. Perfect. And now we need to say, okay, well, how many 250s can I split that into? Okay, so I need to do 5,000 divided by 250. Now, when you've got a tricky division, it's quite big numbers, I quite like to write it as a fraction and then just simplify that fraction. So 5,000 divided by 250, let's simplify that fraction. Let's divide them both by 10. And that gives 500 divided by 25. And that's equivalent. That's the same question. And now I'm going to divide them both by 5 because I'm noticing that both those numbers are in the 5 times table. So that would be 100 over 5. And now it's a little bit easier for us to do. 100 divided by 5 is 20. The other way to think about it is 250, 500, 750, 1,000. So every 4 makes 1,000. And because I've got 5,000, I can do 4 times 5, and that's 20 as well. So a couple of different ways of doing it. And then we need to times that by 65p, because that's how much he's going to get for each bag. So 20 times 65. And let's do this by the lattice method, just because I love it. It's a great method to do. So 65 times 20, split every box diagonally. 5 times 2 is 10, so that goes there. 5 times 0 is 0, so we just put 0, 0 down there. 6 times 2 is 12, so that just goes there. And 6 times 0 is 0, so that goes there. You then just add down each diagonal section. So just 0 in that first section. 0 add 0 is 0. 2 add 1 is 3. And then that last section is just a 1. And because it is 65p, it's got a decimal point here, because I want to get my answer in pounds, and 20 has a decimal point here. You go down with one decimal point and across with the other, and wherever they meet, that's where you go down the diagonal, and that tells you where to put the decimal point. So this is £13. So what's her profit? Well, she spent £10 in the first place. So £3 profit. And when we're calculating profit, we do the profit over the original times by 100. So profit is the extra money you've made over the original times by 100. So that's £3 out of £10, which is what I spent out originally, or what Renee spent out originally, times by 100. Now 3/10 is 0.3 times by 100 is 30% profit. And that makes sense in this case. £10, £3 out of £10, we know that's going to be 30%. So well done if you got that. Perfect. 30% profit. Okay, question number 5. Here is a solid square-based pyramid, VABCD. The base of the pyramid is a square of side 6. The height of the pyramid is 4, so that's going straight up. M is the midpoint of BC, and VM equals 5. Draw an accurate front elevation of the pyramid from the direction of the arrow. So they're asking you, if we're looking at it from this direction, what would it look like in 2D? What would it look like straight on? Now, you'd only see this face. You'd only see this triangle here. If you were looking at it dead on from that direction, you wouldn't see the side. You'd just see it dead on. How tall would it be? So when you're looking at it, it would be 6 wide, we can see that from the base there. But the height, it's a little bit confusing because they've said it's 5 centimetres, but they've also said it's 4 centimetres tall. Now 5 centimetres is the distance diagonally across that face. But looking at it dead on, the height going straight up is just 4. So when I'm drawing this, I need to make sure that I'm drawing a triangle that is 6 wide and going up by 4. Yes, this sloping distance is 5, but that's not very helpful for this. We just want to make sure we draw it 4 up. So I'm going to get my ruler here and I'm going to draw it 6 wide. So 1, 2, 3, 4, 5, 6. They've told me it's centimetre grid, so I don't need to use my ruler. And we're going up by 4. Now I'm going in the middle here, 1, 2, 3, 4. So I know I need to go up to this point and then just make it symmetrical like that. There we go, and that's the front elevation of the pyramid. Work out the total surface area. So for surface area, you want to think about the area of every single face added together. So if I just unfold this pyramid, it would look a little bit like this. I know that the square is 6 wide and 6 tall, and I know that the triangles, they have a height of 5, because when you lay them flat, it's going to be that diagonal length. That's the distance from the bottom of the triangle to the top of the triangle. 4 is just how tall it ends up being when you slope the triangles. So 5 is the height of those triangles when you lay them flat. So they are going to be 6 wide and 5 tall. So the square is 6 times 6, which is 36 centimetres squared. And then each of the triangles is base times height divided by 2 for the area of a triangle. So 6 times 5 divided by 2. So 6 times 5 is 30, and 30 divided by 2 is 15. And I've got 4 of those triangles, so 15 for this one, 15 for this one, 15 for this one, and 15 for this one. 15 times 4 is 60. So I've also got 60 centimetres squared for the triangles. Adding that together, our total surface area, the area of all the faces added together, is 96 centimetres squared, because we're working in centimetres. Note that there was no units there, so you're going to get a mark for putting the units in regardless of your working. Question number 7. Shape T is reflected in the line x equals minus 1 to give shape R. So let's draw that mirror line in. X equals minus 1 is the line that goes through minus 1 on the x-axis. A little bit confusing because the x-axis goes this way, so people get confused. When it's x equals, it goes through the x-axis and it goes through at minus 1. There we go. So we've got to reflect it in that line first, and then we're going to reflect it in y equals minus 2. Now a line y equals minus 2 goes through minus 2 on the y-axis. So first we're going to reflect it in the line x equals minus 1, and we need to make sure that we're the same distance from the mirror line. So here we are 2 squares away, so we're going to stay 2 squares away on this side as well and draw our triangle there. Now you can reflect each point if you want. Some people find it easy to see, others find it a little bit more challenging. So you can reflect each point, count each point, see how far it is away, or you can just do one and draw it from there. But there we go, that's reflected, same distance away, and then we need to do the same down below here. So we're now going to reflect it in that mirror line. Y equals minus 2 is 3 squares away, so we need to make sure that when we draw it, it stays 3 squares away on this side, and it's going to go down here like this. We're then asked to describe the single transformation that will map T onto S. So S is our new shape. This one's S, this one was R. We want to know, how has this triangle here got to this triangle down here? And that's happened with a rotation. If you go from T to S, it's actually rotated 180 degrees around this point. And that will always happen. When you reflect and you reflect again, it's actually always going to be a rotation 180 degrees around the point where those two mirror lines crossed. That's going to be a rotation 180 degrees. Now we don't need to say clockwise or anti-clockwise because it doesn't matter. If you're going 180 degrees, it's just upside down, so it doesn't matter which way you go. Around the point, minus 1, minus 2. And that's going to be your 2 marks for that one. Question number 9. Write down the value of 36 to the power of a half. Now the power of a half means we square root. Don't halve it. So the most common mistake I'd see on this question is people writing 18, okay? So we're not halving it. It's not 36 times a half. That would be 18. And 36 divided by a half actually doubles. But the power of a half means square root. So 36 to the power of a half is the same as the square root of 36, which is just 6. So there we go, 6 for that one. Write down the value of 23 to the power of 0. Anything to the power of 0 is 1. So if I asked you 5 to the power of 0, that would be 1. If I asked you 7 to the power of 0, that would be 1. Okay, anything to the power of 0 is just 1. So 23 to the power of 0, just 1. And then we're asked to work out the value of 27 to the power of minus 2/3. Now this one is a bit more tricky. When we have a power that is a fraction, we root by the bottom and we do the power of the top. But we also have this negative to think about. Now when a power is negative, it makes the base number its reciprocal. So reciprocal is just explained again. 2/3, the reciprocal would be 3/2. 4/5, the reciprocal would be 5/4. But if you have a whole number like 27, then the reciprocal is going to be 1/27. So I'm going to start by writing the question as it is. 27 to the power of minus 2/3. That equals 1 over 27 to the power of 2/3. So what I've done there is I've used up that negative by making the base number its reciprocal. So I've dealt with that. I've used that. I'm now going to cube root. So the cube root of 1 is just 1. And the cube root of 27 is 3, because 3 times 3 times 3 makes 27. So that's going to be 1 over 3. And then I still need to do the power of the top number, that 2. So that squared is going to be 1 over 9. 1 squared is 1, and 3 squared is 9. So there we go. A really, really common question for the non-calculator paper. You obviously haven't got your calculator to be able to type those in, so they like to assess that on the non-calculator paper. Question number 11, and we're definitely on to the harder questions now. So A and B are points on a circle's centre O. BC is a tangent to a circle. So a tangent is a line that just touches the edge of the circle. So you've got a circle, if you've got a line here that just touches it, I've not actually drawn that very well, but just touches it there, that's called a tangent to the circle. It's not going to go inside it. And always, when you have a tangent, the radius and the tangent will always make a right angle. So if I drew a line here going straight up, I know that this would be 90 degrees, and that might come in handy in a minute. But let's read the rest of the question. AOC is a straight line, so that's going here, that's a straight line, helpful, and angle ABO is X. So let's draw that in. Angle ABO, so you're going from A to B to O, like that. That angle there is X. Find the size of angle ACB in terms of X. So ACB, you want to go from A to C to B. So the angle that's being formed there is at C. So that angle there is what they're asking you for. And they want it in terms of algebra. They've not given you any angles, so you don't actually know how big any of these angles are. We're just going to work with it with X. So first things first, I have a radius here and I have a radius here. And what we know about circles is that radii, the plural of radius, radii are always the same length. So the distance from the middle of the circle to the edge of the circle doesn't change. So I therefore know that this length here and this length here are equal, which makes that triangle AOB an isosceles triangle. So I also know that this angle here is also X, because base angles in an isosceles triangle are equal. So I'm going to start with that. We do have to give a reason for each stage of our working, so we do need to write that down. So I'm going to start by saying angle OAB, which is the one we've just drawn in, equals X, because radii are equal, which makes an isosceles triangle base angles in an isosceles are equal. So that's the first thing. So we know that that's X. I now want to put that 90 degrees in. So that's because we said earlier that if you have a radius and you have a tangent, they always make a right angle. So let's write that. Angle OBC equals 90 degrees because radius and tangent always meet at 90 degrees. Great. So now I'm going to look at this triangle here. So from here to here to here. That is a triangle, and we've got all of the angles in that triangle now except the one they've asked us about. So I know that this angle here and this angle have to add up to 180 degrees because that's angles in a triangle. So I know that X add 90 add our question mark needs to equal 180 degrees. So we want to work out what is that question mark? What is this missing angle? And we know that this is true because angles in a triangle add up to 180. So let's write that. Angles in a triangle add up to 180. Perfect. There we go. So now I'm just going to get that question mark on its own by taking stuff away from both sides. Let's do it up here so you can still see. X, add 90, add that question mark equals 180. So now let's take stuff away from both sides. Let's take 90 away from both sides. So we've got 2x. I'm just going to collect those together. Add the question mark equals 90. And then if I want to know what that question mark is, I'm going to take 2x away from both sides to get it on its own. So that question mark, I really should have called it y or something, shouldn't I? Is 90 minus 2x. And that is your answer. So 90 minus 2x is the answer. It did say in terms of x. I'm just going to put it down here just as a final conclusion. Angle ACB is 90 minus 2x. There we go. And we've got the reason for that just up there. Wonderful. Tricky one, that. Well done if you followed along or if you got that one. That was really hard. Question number 13, and we've got some surds. Now, surds, remember, are just square roots. So if I asked you what the square root of 9 was, you'd say that's 3. If I asked you what the square root of 4 was, you'd say that's 2. But if I asked you what the square root of 5 was, it's not a whole number and we don't know it, but we know it's a little bit bigger than 2 and it's smaller than 3. So maybe it's 2.1 something or 2.2 something, I don't know, but it doesn't really matter. Because we don't want to work with a decimal that goes on forever, we just leave it as root 5 and we call it a surd and we can do stuff with it, okay? So I'm going to expand this out. I've got root 5 times this bracket, so I'm going to start by multiplying this out just as I normally would. Now, the wonderful thing about surds is that you can multiply surds together. So root 5 times root 8, that is root 40. And root 5 times root 18, that is root 90. Because 5 times 18 is 90. And because they're both in a surd, you can times them together. If I asked you to do root 5 times 2, then you would write that as 2 root 5, because one of them is a number and one of them is a surd. So you can't make that 10, okay, if it's one of each. But if they're both surds, then you can times them together. Great. We've now got root 40 add root 90, and we're going to simplify that. Bit of a clue here, because they're saying write it in the form something root 10. Now with surds, in the same way you can times them, you can also split them up. And when you're simplifying a surd, you are looking for a square number, because square numbers can be square rooted. So if I gave you the square root of 16, you can tell me that that is 4. So we want to kind of spot those numbers as factors if we can. So I'm going to write out all my square numbers: 1, 4, 9, 16, 25, 36, 49, and so on. So these are all your square numbers. And if any of those go in as a factor, then we're going to want to do that. And we want to use the biggest one that we can. So I'm going to take root 40. 4 is the biggest square number factor. So I'm going to change this to be root 4, root 10. And then with the root 90, 9 is a factor. So I'm going to change that to be root 9, root 10, because 9 times 10 makes 90. So you're looking for the biggest square number you can. You're going to put it first and you're going to divide 40 or divide 90 by that number. Now the square root of 4 is 2. So this is 2 root 10, and the square root of 9 is 3. So that's 3 root 10. And then because these parts are the same, you can't normally add surds unless the surds are the same. So 2 lots of root 10, add 3 lots of root 10, that is 5 lots of root 10. And all they've asked for on the answer line here is the A part. So they've told you that there will be a root 10. They just want to know what is A, what is the number that is in front, and so that is just 5. Okay, question 15. Factorise a squared minus b squared. Now this is a difference of two squares question. When you've got a square number, take away another square number. If I asked you to factorise x squared minus 100, you would do x plus 10, x minus 10, because you're going to square root this and put it at the start of the bracket, and square root this and put it at the ends of the bracket. So x squared minus 64, that would be x add 8, x minus 8. And if you're not familiar with that, maybe multiply a few of these out and just see what happens. Practice your expanding and that might make a little bit more sense. Okay, perfect. So factorise a squared minus b squared. That's going to be a add b in the first bracket and a minus b in the second bracket. And that's the square root of each of those things. And that is a difference of two squares question. There we go. If I could times that out just to prove the point, a times a is a squared. A times minus b is minus ab. B times a is plus ab. And b times minus b is minus b squared. And if I'm taking away ab and I'm adding ab, they're going to cancel out. So you're just left with a squared minus b squared. So that does give you that. So that's factorised. Our answer there is a plus b times a minus b. There we go. Question B, hence or otherwise simplify fully this. So this question is a harder version of what we've just done. I want you to visualise that this is your A, and this makes it A squared, and this is your B, and that makes it B squared. So a really, really difficult question. We're going to do exactly the same thing. The A forms the front of each bracket, and the B forms the end of each bracket. Still the difference of 2 squared, it's still just something squared, take away something squared. So we can do exactly the same thing. So I'm going to put x squared add 4 and x squared add 4 at the start of each bracket. That's our A. And I'm also going to put the x squared minus 2 at the end of each bracket. In the first bracket, we're writing that as an add, and in the second bracket we are subtracting. Now remember that you're subtracting all of that b, so we're going to take away the x squared but also take away the minus 2, and that makes a plus 2. So simplifying this down, I've got x squared add x squared, so that's 2x squared, and then I've got 4 add minus 2, which is just add 2 in that first bracket. And in the second bracket I've got x squared take away x squared, which is nothing, but I've got 4 minus 2, which is 4 add 2, and that is 6. So I'm multiplying 2x squared add 2 by 6, which is 12x squared add 12. And that is simplified fully. I kind of want to factorise it just because I can, so I'm going to put 12 on the outside and leave it as 12x squared add 1, but this would be absolutely fine. For 3 marks, that is fully simplified. There we go. Very, very difficult question. Well done if you got that. Okay, question 17. And here we've got a fraction. Now, what a lot of students do on this question is say, well, I've got x squared on the top and I've got x squared on the bottom, and they just get rid of them like that. You can't cancel a fraction by subtracting. If I said to you, I've got the fraction 3/4, you can't just say, well, I'll take away 1 from the top and take away 1 from the bottom and get 2/3. That's not an equivalent fraction, okay? So we're not going to take away anything. We're just going to divide. The only way to simplify a fraction is to divide. And the only way to divide is to find a common factor. So if you want a common factor, you need to factorise. And that's going to find you any common factors. Now with this, I'm going to factorise. The numerator is a quadratic. And so this factorises, remember factorise means putting it into brackets. This factorises into 2 brackets. And it's going to be 3x and x to make that 3x squared, and we'll look at the rest of it in a minute. The denominator only needs 1 bracket, and that's because they've got things in common to their terms. So I'm going to take 2x outside the bracket and then open the bracket. 2x is the biggest factor they have in common, and then put in the inside. So 2x squared, I'd need that to be an x minus, and then I need that to be 3. And then when you multiply that out, that would give you 2x squared minus 6x. Now that's given me a big clue because I know there's going to be a common factor here. So I'm going to guess that this bracket up here is also going to be x minus 3. So let's use that to help us. That means that this one needs to be plus 1. Because I need to multiply to make minus 3. So when you times this out, 3x squared minus 9x, add 1x minus 3. So yeah, that works. That makes that correct. Now we're looking for a common factor, and you can see x minus 3 and x minus 3. So we can divide the top of the fraction by x minus 3, divide the bottom of the fraction by x minus 3, and that's going to be 3x add 1 over 2x. There we go, and that would be your answer. You can't simplify that any further because there's nothing in common to all of the terms. So if you were to say, oh, there's an x on the top and an x on the bottom, yeah, we could divide by x, but you can't divide this bit by x, and that's why that is finished as it is. Question 19, the point P has coordinates 3, 4, and the point Q has coordinates AB. A line perpendicular to PQ is given by the equation 3x add 2y equals 7. Find an expression for B in terms of A. So this question immediately is talking about gradient. If we're talking about perpendicular lines, okay? So remember that 2 lines are parallel if they're going in exactly the same direction, and that means that they would have the same gradient. If 2 lines are perpendicular, that means that they are meeting at a right angle. So I've got 2 lines like this and they're meeting at a right angle, and that means if this gradient was minus 2, this one would be positive a half. So you make it positive or make it negative depending on whether it's positive or negative to begin with, and then do the reciprocal. So remember 2, the reciprocal of 2 is a half, the reciprocal of half is 2. If you had this line with a gradient of 3, then the perpendicular line would have a gradient of minus a third, okay? So we're talking about perpendicular lines here, so that information is going to be helpful. The first thing we've been given is the equation of a line. So the equation of the line is 3x add 2y equals 7. That tells us lots of information. We can get the gradient from that. So 3x add 2y equals 7. It's not in the right format at the minute, but if I make y the subject of the formula, then I can look at the coefficient of x and work out what the gradient is. So we're going to start by rearranging this. I'm going to take 3x away from both sides. So 2y is 7 take away 3x. And then I'm going to divide everything by 2. So y equals 3.5 minus 3 over 2x. I'm going to leave that as a fraction because I want to do the reciprocal. So I've divided by 2, I've divided everything by 2, and now I can see that the y-intercept would be positive 3.5 or 7 over 2, and the gradient would be minus 3 over 2 of this line, okay? But remember that we're not after the gradient of this line, we want to go perpendicular, so we need the negative reciprocal of that. So this line has a gradient of minus 3 over 2. Our line must have a gradient that is the negative reciprocal, which is going to be positive 2/3. So this line, PQ, has a gradient of positive 2/3. So I therefore know that whatever these coordinates are, if I do rise over run or change in y over change in x to get the gradient, it has to equal 2/3. So gradient is the change in the y coordinates divided by the change in the x coordinates. So I'm going to do b take away 4, that would be the change in the y coordinates, divided by a take away 3, that would be the change in the x coordinates. And we know that needs to make 2/3. So I'm going to solve that equation. First thing I'm going to do is multiply both sides by 3. So to multiply this side by 3, that's just going to be gone. And to multiply this side by 3, I just want to times the top. So you can always imagine it going up like that. Same with this side. I'm going to multiply both sides by a minus 3. So that's going to go up there. So I've now got 3 lots of b minus 4 equals 2 lots of a minus 3. And expanding that out, I get 3b minus 12 equals 2a minus 6. Now the question says find an expression for b. So we want b on its own in terms of a. So to get that b on its own, I'm going to add 12 to both sides. So 3b equals 2a add 6, because if I'm at minus 6 and I add 12, that's going to come up to positive 6. And then I want to get that b on its own. So b equals 2/3 a add 2. So I've divided this by 3, divided this by 3, and divided this by 3. You could also leave it as 2a add 6 all over 3. That would be absolutely fine for the marks as well. So there we go. It would be, how many marks? 5 marks for either of those. So 5 marks for that one, or 5 marks for that one. Well done. That is the end of that half-past paper. Now remember that I'll pop the grade boundaries or similar grade boundaries in the description. This is a half-past paper. Those end questions are going to be grade 8, 9. So if you are aiming for a grade 4, 5, 6, don't be put off by the second half of the paper, and make sure you're really confident with the first half. I hope you enjoyed it. I'll be filming week 2 and that will be uploaded shortly.